Moving on to the advanced question. So it's Pew Research in November 2011 pulled a random sample of 799 US teens about internet use. 49% of the teens reported that they had misrepresented their age online to gain access to websites and online services. So part A is asking us to find the margin of error if we want a 95% confidence in our estimate of the percent of American teens who have misrepresented their age online. So, as a reminder, the margin of error is found by plus or minus the z-star square root pq over n. So we just simply have to plug in the numbers. So for a 95% confidence, the z-star value is 1.96, then square root p is the 0.49, and then the q is the 0.51. The p is representing the probability for success, as stated that 49% of the teens said that they did, and the 51, the q is the unsuccessful. Then the n is just the 799 teens. So when you do the calculations, you'll get plus or minus 0.0347. So the margin of error of teens who have misrepresented their age online is a plus or minus 0.347 from the value of 0.49. So then part B is just asking for us to explain the margin of error. So the margin of error means we are 95% confident that the true proportion of teens who've lied about their age is within 0.347 above or below the given average of 0.49. In other words, I guess you could say is that we're 95% confident the true proportion is between 0.4553 and 0.5247. So whenever I say the plus or minus, the margin of error, it really means below or above. So then part C, if we only need to be 90% confident, will the margin of error be larger or smaller? And then they're asking us to explain it. So the margin of error will be smaller if we only need to be 90% confident, because the margin of error is found by plus or minus z-star square root pq over n. So therefore decreasing to a 90% confidence from a 95, you will get a lower z-star value, and that will go from 1.96 to 1.645. A lower z-star value will produce a smaller margin of error.